Hey everyone, I hope you're having a good Hashi talk so far. Unfortunately, I'm traveling the week of, and I won't be able to do this live anymore, but ends up working out. I'm going to do a little bit more hands-on and screen shares to show you a couple of homelab resources and my setup. So with that, we'll get started. So with this, I'm just going to do a brief intro of who I am, talk about homelab resources to kind of give some ideas and spark a little bit of creativity on what you want to add into your home lab. After that, I'll talk about my home lab hardware that I set up. It's very simple. And then lastly, before we start um, getting into the demos, I'll talk about setup and design, what I want to add into my home lab and how I'm going to get it all to communicate. And then I'll go into provisioning demos, which will be Packer building templates, and then Terraform taking those templates and building VMs from them. And then lastly, I'll talk about deploying applications in your home lab on top of Nomad. So with that, we'll go ahead and get started. So I'm Ben Lykins. I'm a resident solutions engineer here at HashiCorp. I just started about 2 months ago. I dropped in my Blue Sky handle there. I don't really post much on Blue Sky, but there are a lot of good advocates, technical advocates out there, a lot of Hashi folks. So recommend go there and see what they're posting, talking about. Also have a blog. I haven't really done much with my blog recently due to the holidays, but hopefully need to kick it back up. So why am I doing a talk again? So this is now my second public talk that I'm doing. First time I've ever done a public talk was at HashiCorp 2024. My goal there was I didn't know Nomad that well. I'd heard of it, but never really used it. Wanted to give myself an opportunity to learn it, so I put in a talk saying I'm a beginner. I want to learn Nomad. I want to deploy a solution with it. Talk got accepted, and then within 30 days, I had to build out a solution with Nomad. If you were at my talk, I had a fanny pack. I'm not going to wear a fanny pack this time. I had a couple of devices in my fanny pack to pull it out and show how lightweight and limited compute you need to run Nomad. So next, HashiStack. Building out a home lab will give me an opportunity to work with a HashiStack and showcase that it's not for enterprises and just for the cloud. I'm using it in my home lab, which is very lightweight. Doesn't have really the robust features or support that many of the cloud environments do, but I can use those tools to help build it up from the ground up. And then lastly, just to give back to the community, I honestly wouldn't be where I'm at today if it wasn't for the community and others sharing their experiences and posting online and making these kinds of videos. So this is me giving back and hopefully giving inspiration for someone to pick up a new project or promote something that they're working on. This next section, I'm going to go over home lab resources that I used. These are sites, repositories, just to get some ideas and inspiration when building out my home lab. So I'll see you over there. So to start out the resources, the first one I'm going to show here is self-hosted. What's nice with this is if you have a hosted solution that you want to look to self-host, you can do a drop down here and say if you want to self-host a repository, you can select something like GitHub and it will give some options out there. The next site is Awesome Self-Hosted, and it's just a good list of open source solutions out there that they maintain and keep track of whether they're still active or not. Next is going to be building out a home lab, and before you build out a home lab, I'd recommend running something like Multipass. That's a very easy solution if you're familiar with Ubuntu. If you want to spin up VMs on an existing machine, Multipass is something that's simple that can do that. Just recently, Broadcom allowed VMware Fusion and VMware Workstation Pro. They released them for free. So this is another solution before having to buy new hardware. You can run this on existing hardware. And then if you are looking at getting hardware, I'll recommend Serve the Home, site I check out every now and then. The main post I'll say that got me really interested in hosting is their tiny home lab project that they did. And these are essentially, if you think of a lot of businesses will run these kind of devices, these are things that you can pick up for cheap. They usually have good CPU, decent memory, and you can buy a couple of them. But the last one I want to mention is this Chick-fil-A blog post, and you'll see where this is where my home lab hardware came from. So essentially Chick-fil-A runs their essentially remote edge operations on Intel NUCs. It's very lightweight and it's very efficient. You don't have to pay much for power. So this is kind of where I got my idea from. I didn't get Intel NUCs, but I'll show which equipment I got. So you'll see that when I move into the next section. So for my home lab hardware, it's a pretty lightweight setup, as I mentioned. I got 3 mini computes, and these are very lightweight. I have them pretty much just stuck in my basement right now. You don't have to have a server rack or anything else to really support them. They are energy efficient chips, say Intel 100, so I'm not really paying much for my electric bill to get these running compared to buying a fully blown server. But I am kind of limited when it comes to compute and RAM. The RAM itself is soldered to the board. The storage, I end up using a decent chunk of it for Proxmox. I do add some SSDs to each of the nodes. And then the nice feature with it is they do have 2 NICs on the back. Lastly, the other thing that I have is an unmanaged 12-port switch. That's to get those all connected and then connected back to my home network. And that's about it. Nothing too expensive, nothing too robust to get set up. So this section is going to be the setup and design that I planned out for my home lab. So I have the 3 compute nodes. I set up Proxmox on them. I join them into a cluster. For storage, there's both the local storage that Proxmox uses, and then I also set up Ceph, which integrates with Proxmox pretty smoothly. I end up using that in my Nomad cluster, which I'll show you later on. And then lastly, networking is very simple. I use Pi-hole for my DNS. I only need a couple of records, and I don't need anything robust. So that's pretty much as simple as you can get with getting DNS set up. I also do use HCP Terraform, so instead of running Terraform locally on my computer, I wanted to get a fuller experience. So I set up HCP Terraform, I sign up, I get my first organization set up. I'm going to create an agent, which if you're not familiar with agents, it's essentially an extension to HCP Terraform to allow you to connect privately. So for mine, it's going to connect to my home lab, and it'll allow the runs to run there securely. So next, very simple integration. So I'll have Packer building out the images. Terraform's going to provision the images that Packer builds out. Terraform's also going to provision the VMs for the Nomad cluster, and as well, Vault will be there. I'm not going to talk too much about Vault, but there are integrations that all 3 of them use, and Vault's pretty much my central secret management solution. Next, I'm going to set up an external load balancer. I'm not going to do a demo on it, but essentially I'm going to use HA proxy. I'll set up Traefik on my Nomad cluster. HA proxy will do the health checks and the load balancing. So if a Traefik node does go down, HA proxy won't route it to that dead service and route to a healthy service. And this is kind of oversimplified, but I am going to set up Traefik, as I mentioned, and I will use Nomad's native service discovery. So essentially, I'll set up a rule on Traefik, and in my example here, if I have Traefik Lykins.local, and then it's going to go to a path of service, Traefik will direct that and route it to any clients that are up and healthy with that. If the client moves to a different node, it will register back with Traefik, give it the new IP address, give it a new port if it has a new dynamic port. I'll showcase that, the Traefik and Nomad service discovery integration. So we're at a point now that we're ready to start provisioning. With my lab, the first thing that I'm going to set up is HCP Terraform. I'm going to set up the agent. So I'll walk through a demo of how to get that set up and running. So I will see you in the demo. For this, I already have an instance set up, and I already downloaded the TFC agent and unzipped it. So what I need to do now is go into my HCP Terraform instance, went into settings, went to agents. I need to create my first agent pool. I will call this HashiTalks. And I need to create my first token, and I will call it homelab. And I'll create the token. grab the information from it. This will give you an agent token. I'm going to have this deleted soon after, so I am fine getting it or showing it to you all. And I will call this TFC agent. And then what's left is I just need to run the agent. You can see that's all you need to do now to set up. Once I do my Terraform run, I'll show you how you can pick up and use this agent to run private in your private networks. So hold off to that, but next we'll talk about the Packer setup. So we are getting into the Packer demo now, and I just realized I forgot to say in the last demo, I do have a video for my keyboard to show that I'm actually doing work for this. But not too much work. It's a lot more copy and pasting. But with my Packer builds, I typically try to do as few templates as possible. And in this case, I only have a single template. I call it base. So all my ISOs will get built out in this base template. This is done via a lot of dynamic blocks. So shout out to Tom Straub here. This is something I've never done, at least with provisioners, and never realized that you could do, and I never tried it myself. But he figured out you could use the dynamic on a provisioner. For here, I'm using it with files. I have a variable of files that is mapped, and it will loop through it and make sure to copy over all the files for the build. And same thing with scripts. Pretty much works in the same fashion. I have it running in a specific order based on how the mapping works. And usually the last script that gets run is a deprovisioning process. Next thing, I'm using the Proxmox plugin. You can check out the documentation on the HashiCorp docs website for Packer. And then source, similar thing here. I have dynamic blocks where I need a little bit more flexibility, so things like disk, networks. And then these are also being built directly from ISOs. So essentially Packer will boot up an HTTP server. It will serve this pre-seed config on it. The ISO, when it's building out, will grab the pre-seed config and do an auto unintend install. And then variables, I have split up between the builds and Proxmox provider, but then for anything that will be shared among builds, I have a shared directory. So files, these mainly are going to be for my Nomad setup. So my the service for Nomad, my Nomad config for client and server. HTTP is going to be my pre-seed config file, and then all my scripts will be in a scripts directory. And then instead of having multiple templates, you can see here I have a base client server. These are essentially just how I make different builds and templates instead of having multiple Packer template files. So to show what it looks like, if I was going to create a new template, I will just, for simplicity's sake, copy over another one. I will call this demo.pkrvars.hcl. And I will call this HashiTalks. And then Proxmox use ID, the provider plugin. It will dynamically allocate one, but I do statically just so it makes it easier for Terraform to pick up. So I will do 300, specify the node, MF1's fine. And then this is how the dynamics work. You can see I have the disk here. If I had multiple, it'd be 0, 1, 2, 3, and I can configure them how I'd want. And then same thing with the scripts, 0, 1, and so on. So if I had wanted to add another script, I could just do this, 2, and then update the pathing for the script. But with that, I am going to go ahead and do a quick run. So I will do Packer build, and then var file is equal to Packer var file. This is demo. And we'll get that cleaned up here so this actually runs. And then I need to specify the template. So Packer builds base and then dot. So it is now connected. I am going to jump into my Proxmox environment, go to MF1. You can see here the VM ID 300. it's booting up from the ISO. It's waiting a few seconds for the boot process to go. Goes into the BIOS here, and see it kicks off. It puts in the boot command here. It points to the HTTP server, and we should have an unintended, yep, install kickoff. So this would take a little bit because it does have to do a full install and the scripts that I have set up. So I'll probably cut the video short, but I always like to show off this process since if you're working in the cloud or some other environments, you don't really get to see what it's like to build a image from scratch. So I'll see you in the next demo where we are going to start provisioning VMs from these images using Terraform. So now we have our templates created and we are ready to provision our VMs. I already have a simple repo set up with Terraform. It's pretty static. It's going to set up a server, which will be Nomad and Vault, and then future Consul running on it, and then a couple of clients, which will be the Nomad clients and Consul clients running on it. And lastly is the HA proxy, which will do the external load balancing. And we are going to get it deployed using the TFC agent in my private network. So I'll go ahead and get the project set up called homelab. And it's the Terraform working directory. Yes, yes. That's good. All right, I kicked off the first plan, but realized I needed to make one more update, so I will cancel. The update I need to make is the execution mode. I need to set up the agent. HashiTalks is the only agent pool. I'll hit save, and we will do a new run. And so what we should, oh, that was quick. So what we're seeing is the job's been picked up, has the run ID. It does the Terraform init. It's currently doing the plan right now. Since I set this up to do auto apply, it should pick up the apply run here pretty soon. And then essentially the steps are server, HA proxy will come up first. Once the server's up, the clients will come up afterwards. And since not Nomad, since Packer did all the configuration prior, I won't need to do any secondary steps once this is done. So once it is provisioned, I will go ahead and jump into my Nomad server. So I'll probably speed up the video here and leave it running. So the job finished up running, and what I should be able to do now is hit the Nomad server. And you can see there is a single server with the homelab data center, and then 3 clients, and then the other vault.lykins.local. Oops. So Vault also is ready to get set up as well. But for this HashiTalk, I'm just going to focus on Nomad, and we'll start doing demos of deploying jobs to Nomad. So I will see you then. So now we're ready to move to deployment. We had Packer deployed the templates that Terraform used to provision VMs from, and now we are ready to start deploying our first job. So the first job that we're going to deploy, and it's going to be the only one, but I'm going to build from it. It's called Swing Music, and essentially it's a music player. So if you have any local music that you have backup copies of, or old music that you've had downloaded, you can get it added into here and you'll have a nice UI to play your music. They are also working on a mobile app, and this project was one that I found on the Awesome Self-Hosted, so definitely check it out, like it, and give it a shot. So what we'll do is we'll do it in 3 simple steps. We will deploy the basic job. So it's just going to be the Docker container up and running. After that, we are going to add networking to the job. So we'll integrate the Nomad service discovery and put in a Traefik integration into it. Traefik will be load balanced behind the HA proxy that we deployed by Terraform. And then lastly, we're going to add persistent storage. We're going to use the Ceph CSI. We already have Ceph set up on our Proxmox, and all we will have to do is create a volume and add a couple of jobs for the CSI, for the controller and the nodes, and then we'll be able to add and mount those volumes to the job. So with that, let's get started. We are going to deploy our first container on Nomad. We're ready to run our first job on Nomad. I do want to note that although I'll be mainly running it through the UI, you can also run it through the CLI. You can also do API, you can do Terraform, you can do Nomad packs, which I demoed in my HashiConf talk. But to get started, if you were going to use the CLI or creating your first new job, you can always do Nomad job init. It will create an example file to get started. I'll do cat example to show what it looks like. Very robust. In our example, it won't be as robust, but it is a lot more detailed if you need to create your first job. So for my first job, I am going to run SwingMX, which is a music player. And when I get started with it, I usually look for any Docker run examples or Docker composes to see what's needed. You can see you just need to grab the image, you add some volumes to it, and you need some ports, and that's it. This one is very simple. You don't need any other task or jobs running for it to work. So with that, I had already created a job. Very basic for this. We'll get it up and running. And I forgot to clean this up before the demo, but you can see that Nomad does validate the jobs prior. And there we go. So it validates. It can run on the nodes. I will go ahead and run. Okay, we are back. The job is up and running now. So what I can do is I can go into the allocation, and Nomad will provide the IP address and the port that it's running on. I can go ahead, click into here, and you can see the service is now up and running. At least the Docker container is. The downside of this is I will always have to hit it by IP address and port. So the next things we'll add to it is networking. So if this goes down, I won't have to worry about knowing the IP address and port. Traefik is going to help out with that, and Nomad's native service discovery will. So with that, we deployed our first Docker container, and I'll see you in the next demos. We're moving on to networking now, and before we get started, I do want to note the Traefik and Nomad service discovery documentation. Very simple to set up. Essentially, it's a tag-based. You do have to have Traefik up and running on your cluster, and a little bit of integration with that, but it's very simple. And essentially what that looks like, I have this set up as a system job, so it's running on every single node versus a service job. If I go into the definition, you can see here I have static network set up for the ports. So for the HTTP, for services coming in, I'll hit port 80, and then for the admin console, I'll hit 8080. You can see here I have this set up to be true to use the Nomad provider integration, and then I also have my cluster endpoint as well, so it can hit the API. But with that, we will go ahead and get our job up and running. And I think the last time I talked about the job spec, I didn't go in great detail. But here I have networking. I'm using Nomad's bridge networking that you can set up. You can also run it on your host. And then Docker, you can also use Docker's bridge networking. But with this, I'm using Nomad's bridge networking. There's a little bit of setup that you have to do on the client, but it's very simple to get set up. The next is we are adding in a service block into the group. So you can see I'm calling this Swing Music. I'm using the Nomad provider. If I was using Consul, I could use the Consul provider that's set up with it. But to get it integrated with Traefik, I just have it set to enable. It's equal to true. I have that entry point, which would be port 80 coming through. And then I have it as a host record. So when it comes into Traefik, it sees that host name. It will make sure to forward it to the right service. And then for the load balancer, the server ports, since this is dynamically mapped to 1970, when it comes up, I don't know the dynamic port that comes up. So to inform Traefik of the correct port, I do have it referencing that value. And then that should be about it. We will go ahead and hit plan. I'll get this run started, and then once it's up and running, I will dive back into it. So it was a little bit quicker to get this up and running. The image was still on the host. It came up on the same host. So it's up and started. I do want to dive in to show the little bit of differences now that I have the service block in there. So if you dive into here, you can see I have the services. I do have the health check coming that's checking for the TCP endpoint. It's coming back up healthy. I do have the integration with Traefik set up. So if I go into the Traefik console, you can see services. I have 5 services showing. The Swing MX service is up and running, and it has the URL that is registered to this. I can go to that directly, and it is showing my Swing MX service. But I can also, since I don't want to use the IP address, I already created a record that points to Traefik for this. If I do swing mx lykins.local is the one that I set up. It's the host rule that Traefik's looking for. It will also direct to the service. So if this goes down on the host or changes any kind of networking information, comes back up, registers with Traefik, I still only have that named address to hit. So with that, we are done with networking. The next step to make this fully deployed would be adding storage, and I'll get more into that in our next demo. So before we get started, I'm going to share over a couple pieces of documentation. So for storage plugins on the Nomad website, you can dig a little bit more into here to get more information on storage plugins. Next, there's a couple of tutorials. If you're new to this and getting started, definitely try out the tutorials, and probably with host volumes first, because that will be the simplest one to set up, but you can get more information and hands-on practice with that. Next, I mentioned I am using Ceph storage. They do have documentation on getting it set up on Nomad. To be fair, I heavily relied / copy and pasted most of this and just did a few updates on it to get it up and running. But it had all the information necessary to get it set up, so that was very helpful. The last piece is the music that I'm getting is, at least copying over for this demo, is from archive.org. But my other goal with this is I was going to back up some music that I got during COVID. I got into vinyls, like other people, I got into hobbies. So this is a vinyl that I could not find any digital record of it being online or any kind of backup of it. So I'm going to back it up myself, and just so I can keep it in case it ends up breaking or getting damaged. So with that, I already set up the 2 jobs that were necessary. The first is a controller that's necessary to communicate with the API. I have a node job set up. This is a system job that runs on every single node to do the attaching of the volumes to the containers. If you dig into storage, you can see the plugins are up and healthy. This is the Ceph plugin that I have set up. You can see the controller, the nodes. You might have also noticed that I have a volume already created. That's an extra step that's necessary. Essentially, all you need to do is, and before I get started, I am going to note, so if I echo, so to communicate with Nomad, I don't have it running locally on this, so I have an environment variable Nomad address. This gets picked up by the command line. You can see it's pointing to my Nomad cluster. For Nomad volumes, you can do Nomad volume and then help. It gives a little bit more information on the volume CLI command. With mine, I'm going to do Nomad volume status. You can see here the volume itself is up and ready. If you want to create an example file, you can do Nomad volume init. That will create an example volume file. But for mine, I created one, and I think it's in a different directory. CD get, let's see, Nomad storage. Oops, wrong directory. Personal, homelab, Nomad storage. Ceph, I think. Yep, cat volume. And that's the example, the volume file I set up. Main thing is to get the access key, which is in key and ID in there, so you can communicate with the Ceph storage. But with that, we are going to close this out. We are going to set up our new job with the storage. So the biggest differences with this, on the group layer, I have the volume. I have the Ceph volume that I created. I'm going to be using this in my job. The next item I wanted to note is I do have these volume mounts set up. The service itself will look for music and configs. So in these directories, I'm just putting a music and config directory and attaching them as well. Since configs will need to be written to, I set up read only to false. So when any config items need to be added in there, it will be writable. The other thing I want to do is you can use Docker volumes. I tend to stay away. I use the Nomad volumes. But in this case, you can use Docker volumes if you do need to have something quick and easy to set up. So this is going to look for something local to the client node that's running. It's the way that I'm going to copy over music. I'm essentially just mounting it to a directory called copy. So I will go ahead, plan this, wait for it to come back up. Once it's back up and running, I will restart the video. So the job's up and running now. I am going to jump to the allocation. And the first thing I notice, I need to get more memory on it. It is throttled. But to get inside the container, if you ever need to do some troubleshooting or some testing, you can easily access from there. I had to copy over some files, so I already went ahead and did that. And then the last thing, I will access my service, and you can see it's now prompting for where to look for music. If I go ahead and select music, I'll add that folder in. I will do a refresh, and now you can see it is up and my music is accessible. So if this does go down, come back up. Since I'm using a Nomad volume backed by Ceph, it will be persistent and I won't have to worry about doing this again. So with that, that's deploying a job in 3 simple steps. We will go ahead and start closing this out. So to start closing things out, if you have any interest in this more, I do have a public GitHub repo. I have my Packer Terraform examples and then my Nomad jobs in there as well as the Ceph storage plugin. So feel free to check it out. I am going to call out a coworker. I was going to mention this a little bit earlier in a different version of this video, but he has a much more in-depth demonstration on using HashiCorp Nomad. He uses different task drivers, runs it on Windows, runs it on Linux, uses the Java driver, and then also creates a Docker container. So it's Learn HashiCorp Nomad, Run Minecraft with Nomad by Joshua Tracy. Goes by the sudo. So check it out. Then lastly, let's give him thanks. So Josh Tracy for me calling out his video and me the stumbling on it and asking for permissions to do it. Kyle Rary, he helps me out with the networking side. He says he didn't help out much, but he helps me out tremendously. Tom Straub, he was the one with the Packer dynamic provisioner example, something I never tried before, but thanks to him, it just helped out creating my templates to make them more multi-purpose. And lastly, the rubber ducky, my youngest, who usually sits on my lap and watches me do work. So thank you all, and I hope you have a great rest of your Hashi Talks, and have a great rest of your week. Thank you.